am going to go through a problem here today that has to do with trigonometric equivalencies, or simplifying. So that we're going to be dealing with our 6 trigonometric ratios: sine, cosine, and tangent, and the reciprocals cosec, sec, and cotangent. I'm going to go through this particular problem. In this problem, you are asked to show that 1 minus cosine theta times 1 plus sec theta is equal to sine theta tangent of theta. Right, so that's the problem. All of the questions that I'm going to do in these videos, I'm going to link in the description in this video. This particular question is question number 20 that I'm going to do. Okay, so how do we go about showing that the product of these two things is actually equal to sine theta tangent of theta? A couple of things out the gate that I want you to always keep in the back of your mind, okay? There's a couple of identities that are very, very important. So the first one is the following. It is sine squared theta plus cosine squared theta is equal to 1. Okay, that is a very fundamental relationship that we will come up over and over and over again. This can also be rewritten that sine squared theta is equal to 1. If I subtract cosine squared theta to the other side, I get 1 minus cosine squared theta. So these two are equivalent. Sine squared theta is equal to 1 minus cosine squared theta, or cosine squared theta is 1 minus sine squared theta. But again, these two expressions are completely equivalent. I've just rearranged the furniture, so to speak. Okay, so this is the first relationship, trigonometric relationship, that is very fundamental that we will use a lot. The second is that sine theta over cosine theta is equal to tangent of theta. Okay? This is a second relationship that we use quite often. We'll notice, for example, we do have a tangent of theta on the right-hand side of our equation up here. So ultimately, even though we don't have a tangent of theta on the left, we're going to have to somehow bring a tangent of theta to this side of the equation. And so it is likely, when we're dealing with sines and cosines, that this relationship, this sine over cosine is equal to tan, is going to be involved somehow. Okay, so that's the second one. And the third, just to mention it, because sec theta is in our question, I will just mention that sec theta is simply 1 over cosine theta. Okay, that's all it is. Of course, this is the same as saying cosine theta is 1 over sec theta. Okay, so although it looks like I have two completely different things here, I have cosine and sec, perhaps I can use this relationship here to have equivalencies, to end up with only one ratio, which would be a little bit easier, I think. All right, so let's get into it. Okay, well, first thing I'm going to do is I'm just going to do the algebra. I'm going to FOIL this out. Okay, I have two terms right here, two binomial terms, and so I'm going to FOIL it out. I go here to here first, outer, inner, last. Right? That's our FOIL technique. So 1 times 1, that's 1. 1 times 1 is 1. 1 times plus sec theta is plus sec theta. minus cosine theta times 1 is minus cos theta. And finally, minus cosine theta times plus sec theta. Well, minus times a plus, that's a minus. And I'm left with cosine theta sec theta. Okay, so that's what I've got. And now I have to show that all of this is equal to sine theta tangent of theta. Okay, so what am I going to do? Well, the first thing I'll do is I will convert my sec theta into 1 over cosine theta. Because I know that sec theta, by definition, is the reciprocal of cosine theta. So sec theta is 1 over cosine. So I will write this as 1 plus 1 over cosine theta minus cosine theta minus cos theta times 1 over cosine theta. I'll put parentheses around this here. So what I've done is I've replaced my sec theta with 1 over cosine theta. What have I gained? Well, if I look at this final term here, I now have cosine theta times 1 over cosine theta. I have a term times its reciprocal. And so I'm ending up with cosine theta over cosine theta. And we know that anything over itself divided by itself is simply 1. And so this term here, this last term here, is actually just 1. This last term, cosine theta times 1 over cosine theta, is just 1. And so, because I have a 1 here at the beginning, and I have minus 1 here, then this first term and this final term will cancel. So that's nice. So this first term, right here, and this last term will cancel for me. So I'm left with 1 over cosine theta minus cosine theta. 1 over cosine theta minus cosine theta. All right, so that's what I have. I still don't have any sines or tans, and that's what I'm ultimately hoping to end up with. So what am I going to do now? Well, when I have two fractions, and you can think about cosine theta as being like cosine theta over 1, if you like, so it's like two fractions. Separated like this, two separate fractions. I want to perhaps bring them together. That might be useful to me, to be able to bring those two fractions here together. So I want to find a common denominator. A common denominator of cosine theta and 1 would simply be cosine theta. Cosine theta. So how do we go about this? All right. We ask ourselves, how many times does cosine theta go into cosine theta? Well, cosine theta goes into cosine theta, of course, exactly once. 10 goes into 10 once. X goes into x once, or x squared goes into x squared once. Cosine theta goes into cosine theta once. So once on 1 times 1 is 1. I have a minus here. How many times does 1 go into cosine theta? Well, how many times does 1 go into 10? 10 times. How many times does 1 go into a million? A million times. How many times does 1 go into x? X times. How many times does 1 go into cosine theta? It goes in cosine theta times. And so 1 into cosine theta, which cosine theta times cosine theta is cosine squared theta. Again, 1 goes into cosine theta times cosine theta is cosine squared theta. Okay, have I gained anything? Yeah, I think I have. I have 1 minus cosine squared theta. Now, I remember that because sine squared theta plus cosine squared theta is equal to 1, that sine squared theta is equal to 1 minus cosine squared theta. This very fundamental relationship. It comes up over and over and over again. So 1 minus cosine squared theta can be written as sine squared theta all over I have downstairs cosine theta. So 1 minus cosine squared theta, I've rewritten that as sine squared theta. Okay, well sine squared theta, again, keep in the back of my mind that this is what I want. I want sine theta times tan theta. So is there anything else I can do? Well, I know that sine squared theta is simply sine theta times sine theta. X squared is x times x. 10 squared is 10 times 10. Sine squared theta is sine theta times sine theta. So this here, I can separate this as sine theta times sine theta all over cos theta. So I separate my sine squared theta into sine theta times sine theta. That is what sine squared theta is. And now I notice that because I have here a sine theta over a cosine theta, here I have sine theta over cosine theta. And I remember, what is that? That is tan theta. So this here is tan theta. Sine theta over cosine theta is tan theta. And so what have I really got here? What I actually have is I have the sine theta, and instead of writing sine theta over cosine theta, I'm going to simply write tan theta. And look at that. I now have sine theta times tan theta. That is what I wanted to prove. I wanted to show that 1 minus cosine theta times 1 plus sec theta was sine theta times tan theta. And I have managed it. That is exactly what I have in the end, so it is proved. And so that is how you go about this particular question. It was a lot of, you had to be pretty good with your algebra, you had to be careful, you had to know how to find the common denominator. But I think as long as you knew that and you knew the fundamental trigonometric identities of sine squared theta plus cosine squared theta is 1, sine theta over cosine theta is tan theta, then I think you can get at this problem. All right, so that is that question done. Thank you very much.